Hi, my name is Anita Jwa, and I'm a postdoctoral fellow at Stanford Psychology. The topic of this presentation is demystifying the risk of reidentification in neuroimaging data through a technical and regulatory analysis. Sharing research data has been widely promoted in the field of neuroimaging and has enhanced the rigor and reproducibility of neuroimaging studies. Emergence of novel software tools and algorithms such as face recognition has raised concerns due to their potential to re-identify neuroimaging data that are thought to have been de-identified. However, the risk of re-identification via these tools and algorithms has not yet been examined outside the limited settings for demonstration purposes. In this study, we'll examine the likelihood of re-identification via face recognition in real-world settings and the regulatory implications of this risk by taking U.S. jurisdiction as a case study. De-identification of neuroimaging data generally includes scrubbing of potentially identifying fields from the data and defacing of structural images. However, in their 2021 study with 157 subjects, Schwartz et al. Showed that neuroimaging data can be re-identified using face recognition even after the data are defaced. The matching rate was 3 to 10% depending on which defacing tool was used. On previously defaced images where the facial structure was imputed using a population average face template, which is called refaced images in the paper, match rates increased to 28% to 33%. At first glance, these rather surprising results raise serious concerns about the adequacy of conventional de-identification methods for neuroimaging data. However, it is important to note that these results cannot be directly translated into the likelihood of re-identification in real-world situations. The re-identification problem is a multi-class classification problem wherein each individual represents a separate class. And it is well known that classification accuracy is necessarily tied to the number of classes being distinguished. For most real-world re-identification problems, the pool of potential matches is much larger than the size of samples in Schwartz et al.'s 157 subjects. Unfortunately, there are no data sets containing both facial photos and MRI images that are of sufficient size to test the effectiveness of re-identification. To test the generalizability of these reported accuracies in real-world situations, we designed a classification problem using simplified data. Test data are generated from a normal distribution by adding random noise to each individual, calibrated to provide two target levels of re-identification performance, 10% for defaced images using PyDeface and 38% for refaced images. Matching accuracies are assessed as the population size varied from 157 to a size large enough to be realistic for a population of potential research subjects. And given the updated likelihood of re-identification from the simulation analysis, we'll further examine whether this risk would place defaced neuroimaging data out of compliance with the regulatory standards for data de-identification in the U.S. This figure shows the identification accuracy results from the simulations. For the higher signal noise simulation, which represents a case of matching subjects' photos with refaced images, identification accuracy dropped from 38.2% for the initial population size of 157 to 0.9% at a population size of 500,000. For the lower signal noise simulation, which represents a case of matching photos with defaced images, identification accuracy dropped from 10.8% to 0.04%. The relationship between accuracy and population size is roughly linear in log-log space, consistent with theoretical results. For the regulatory analysis, we examined whether the risk of re-identification using face recognition would affect achieving data de-identification under the Common Rule and HIPAA. First, the Common Rule is U.S. federal regulations that provide the standards for ethical conduct of biomedical and behavioral research involving human subjects. Under the common rule, secondary analysis on shared data that contain identifiable private information is considered human subject research and should adhere to the rule's two requirements, informed consent and IRB review. Here, identifiable private information means private information for which the identity of the subject is or may readily be ascertained by the investigator. But the rule does not define the term readily ascertainable, and it is left to individual IRB's discretion to interpret and apply this standard. On the other hand, research involving shared data that are not individually identifiable falls outside the scope of human subject research. The rule also does not provide specific methods to make private information not individually identifiable. But a guidance from the OHRP provided that data are not individually identifiable if identifying information has been coded and the release of the key to the code to the recipient of the data is prohibited. However, the OHRP guidance would not be applicable to our analysis because reidentification via face recognition would directly link neuroimaging data back to individual subjects without needing to decipher the code. So we need to go back to the provisions in the common rule to determine the identifiability of deface neuroimaging data. The core question here is whether the identity of the subject is readily ascertainable, and as noted earlier, identifiability of private information is vaguely defined in the rule, and in part due to this probably intentional uncertainties, the rule's bar for rendering data non-identifiable is fairly low. Considering the results of our simulation analysis, it would be difficult to argue that this minimal real-world risk of reidentification would make the identities of subjects readily ascertainable. Next, the HIPAA privacy rule addresses the required and permitted use or disclosure of protected health information, PHI, held or transmitted by a covered entity, such as health plan and healthcare clearinghouse. Unlike the common rule, the privacy rule provides two specific standards for data de-identification, and once de-identified, the data can be used or disclosed without restrictions under the rule. First standard is formal determination by a qualified experts that there exists a very small risk that the information could be used to identify an individual to whom the information pertains. But there is no explicit numerical level of re-identification risk deemed to universally meet the very small level indicated in the standard. Expert determination is rarely used for neuroimaging data, but the minimal real-world matching accuracy using face recognition would probably meet the standard of very small risk. The other standard is safe harbor, which requires the removal of certain unique identifiers from PHI, given that the covered entity does not have actual knowledge that the information could be used alone or in combination with other information to identify the subject. Due to their clarity and simplicity, the safe harbor standard has been commonly used by neuroimaging researchers, regardless of whether they are part of a HIPAA-covered entity. The core question relevant to our analysis is whether being aware of recent studies on face recognition could constitute having actual knowledge that defaced neuroimaging data could still be used to re-identify data subjects. But the guidance from the Office for Civil Rights provided that mere knowledge of studies about methods to re-identify health information does not necessarily count as actual knowledge under the provision. So even if researchers know of the specific studies about face recognition to re-identify neuroimaging data, this will not affect achieving data de-identification under this standard. The results of our study suggest a more balanced view of the real-world likelihood of re-identification in neuroimaging data when weighed against the benefits of the data sharing and open science practice. Any limitations on sharing and secondary use of data should be carefully calibrated corresponding to the specific risk associated with individual data sets to avoid chilling effects on open sharing of neuroimaging data. Best practices for sharing human neuroimaging data would be needed to better inform researchers of the standards and due diligence for sharing their data. Data repositories should also equip themselves with adequate privacy measures for sharing human neuroimaging data. Future development in technical countermeasures to the novel privacy attack would further aid open sharing of neuroimaging data. Thank you for listening.